I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on what this mysterious frictional force is and how it relates to the normal force. Today in this video, we're going to talk about the relationship between the frictional force and the normal force and how it's affected. So let's first define what friction is. We've been using this force, but what is it actually? So it's the force that opposes motion, which we already knew that it opposes motion. It also enables us to walk or drive a car. If we didn't have friction and we tried to walk, it'd be like walking on a treadmill. We're not getting anywhere. If we're trying to drive a car, it's like we're stuck in the mud or we're driving on ice. Now, what friction actually does is at the microscopic level, it's due to the irregularities even in the smoothest of surfaces. So if we look at this crate being pushed to the right, friction opposes it by going to the left. If we zoom in on a corner of that, we can see that the irregularities between the surface and the crate, if we're trying to slide those irregularities together, it's not going to slide very easily. So that's what causes that friction force, is those impurities or irregularities in this even smoothest of surfaces. Now we have two types of friction. We have static friction. Static friction is what occurs before the object starts to move. So static means not moving. And we have kinetic friction, which occurs after it starts to slide. So kinematics, we learned early on, is the study of kinetics, which is motion. So an object moving means that it has kinetic friction. And in general, the kinetic friction is a lesser value than the static friction. It's harder to get something moving than it is to keep something moving. Now, the normal force affects this because the frictional force and normal force are directly proportional to each other. So the bigger the normal force, the bigger the frictional force. That's why friction on a sloping surface is less than friction on a flat surface. As you incline a ramp, the normal force decreases. It becomes mg cosine theta. So let's look at the situation where we have a normal force. We can see those surfaces are not really pushed that greatly together, so the sliding across is going to be a little bit easier. Now, if we apply a larger normal force, we push those surfaces together. It makes it harder to slide across those. So the bigger the normal force, the bigger the frictional force that we have. That's what causes the friction to be greater, is that normal force increasing. So let's look at static friction. So static friction is this equation. It's an inequality, actually. Static friction is less than or equal to mu of s times the normal force, where Fs is the static frictional force in newtons. Mu of s is something called the coefficient of static friction. We'll talk about that a little bit more. And the normal force being directly proportional. So that coefficient is the value that makes it an equality or an inequality in this case. So static friction increases as the force applied increases. So let's look at a physics textbook. So we've got an applied force to the right and a frictional force to the left. The forces are balanced and it's not moving. So that's what it means to have static friction. It's not moving. Now, if that applied force became much larger, but it still didn't move, that means frictional force still has to balance that out. So if an object is not moving, that means it's not accelerating, which means the forces have to be balanced. So the bigger the applied force, the bigger the static friction force is going to be, up to a maximum point. So that maximum point is mu of s times the normal force. So if we exceed that force, mu of s times the normal force, then that means we exceeded the maximum value of static friction, which means that it's going to accelerate. So static friction can't hold it in place any longer, so now it switches to kinetic friction. So that now at this point, the book starts to accelerate because the force is bigger than the frictional force. So now let's look at kinetic friction. Kinetic friction is equal to mu times the normal force. Notice that it's equal to, this is a constant. So between two surfaces, the normal force times the coefficient of kinetic friction is going to equal the kinetic friction force. So kinetic friction is when we're sliding. It's generally less than static friction, as we talked about, which means that it's easier to keep an object moving than it is to get it started. So if we're going to determine the coefficients of friction, so if we looked at the coefficient of static friction, so here's an experiment that you could do to test to find the coefficient of friction between two surfaces. Set a block of one material on an inclined plane made of another. Slowly increase the angle of the block until it just begins to move and record the value of this angle. We can calculate mu of s by just simply doing tangent of theta. Tangent of theta, how do we get that to even work out? So let's look at an example of why it's tangent of theta. So from a previous video, we drew this free body diagram on a sloping surface and found that the normal force is equal to mg cosine of theta. And then we also found, using that same free body diagram, that the frictional force was equal to mg sine of theta from the previous video. So if we're going to determine the coefficient of friction, and we know that the friction force is mg sine of theta and the normal force is mg cosine theta, the coefficient of friction is going to be the friction force divided by the normal force, which is mg sine theta divided by mg cosine theta. Should be coming into picture now. Mg cancels out. Sine over cosine is what we have left, and sine theta divided by cosine theta is tangent of theta, which means mu is equal to tangent of theta. Now mu of s, the static friction coefficient, is the angle the moment it starts to slide. Mu of k would be the angle in which it is sliding at a constant speed. So theta is going to be smaller from u of k. So this is friction and how it relates to the normal force and how you can find the coefficient of friction between two objects. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.